So in this video, we're going to look at how to measure and monitor the rate of reaction and look at a different couple of reactions. So first of all, rate of reaction, the definition. The definition is the change in property divided by the time, or in a given time. You can see here, the change in property can be multiple things, but usually it's the concentration of reactant or a product. But we'll show you three different versions, okay, in which you can do three different units as well. So you can do units for rate through this equation. So the change in property divided by the time. Now, if that's the case, we're going to show you three different types. So change in property for the most obvious one and the one you're going to use in your second year of A-levels all the time, which is change in concentration. So for concentration here, divided by the time. The concentration is always in moles per decimeter cubed, and the time is always in seconds. I say always, but the odd one where it might change, so make sure you pay attention, as the odd examiner tries to mix it up a bit by putting minutes in their time sometimes. Okay, now, if this is the case, you look here and you go, right, okay, seconds is at the bottom, I need it to be at the top, and if I move it from the denominator to the numerator, it's like timesing it by -1. And that means you can create the units for rate, because it would be moles, decimeter -3, and then remember we're timesing it by -1 to get it to the top, so that would be seconds -1. So we have moles per decimeter per second, or moles decimeter -3 seconds -1. Doesn't matter how you say it. Now, if that's the case, let's look at a different change in property, this time volume. So volume is usually measured in centimeters cubed per second. Remember, moving it up is like timesing it by -1, so therefore it's centimeters cubed per second, or centimeters cubed seconds -1. The last one is mass loss. So if in an exam, you might be told that the mass of something is lost over a certain period of time. So here you have the mass is in grams, divided by the seconds, and you're probably getting the point by now, grams per second, or gram seconds -1. Now, producing a gas means we measure the rate in a certain way. Now, the way of doing it if you're producing a gas is to use something called a gas syringe. It's the simplest way of doing it, and in GCSE you would have used an upturned measuring cylinder, and you still do that sometimes now, okay, but the simplest way is a gas syringe. Now, the gas syringe in this one is where magnesium is mixed with acid, okay, and then that produces a gas, and the gas is hydrogen. So we'll look at the equation here. So we've got hydrochloric acid, could be any acid. One thing you might do to make this video more engaging is stop this, change this for H2SO4, try and write that out. Or change it for nitric and try and write that out. Okay, but it is a metal plus an acid goes to a salt plus hydrogen. Now, if that's the case, units you can think about, because we're looking at the volume of hydrogen, which means it is the units of rate are going to be centimeters cubed seconds -1. And the important thing here is we're doing it through volume of gas over time. We don't know the concentration of the hydrochloric acid, otherwise we could use that. We could do it through mass lost, but there's a reason why we don't do it through mass lost. The molar mass of hydrogen is 2, which means you're going to have to lose a hell of a lot of moles to actually lose a lot of mass, because 1 mole is only 2 grams. So you're going to have to lose a hell of a lot, and you just don't on these small scale chemistry experiments, so therefore you don't want to do it through mass loss, the mass of the gas lost, because it's leaving the conical flask. Okay, so what we do is we measure the volume of the gas instead, because at RTP, 1 mole of gas is equal to 24 decimeters cubed in terms of volume, so it doesn't matter whether it's hydrogen or carbon dioxide, it's still going to be a pretty big volume. Now let's look at the next way of doing it. Next way of doing it is mass change. So mass change, you get a balance, and you stick your conical flask on it, and you do similar reaction. This time we've got calcium carbonate chips. Okay, and all we do is stick some cotton wool in there, and that stops the liquid kind of bubbling away and spurting out at the top, and then you lose that mass. Okay, and the gas just goes straight through the cotton wool. And it's for this reaction here, calcium carbonate plus hydrochloric acid. Again, you could stop the video, you could change this for nitric, change this for sulfuric. This time we've got carbon dioxide, okay, and we're doing it through mass lost. So that means grams per seconds, grams per second. In this case, this is 44 grams per mole. Molar mass is 44, which means that you're going to lose quite a lot of mass. 1 mole is 44 grams, so you're going to lose a lot of mass. And that's why you use mass loss for this type of experiment. Remember, you can choose whether it's mass loss or volume of gas, depending on the mass of the gas that you are producing. The only other way of measuring the rate of reaction is to look at the change in concentration, and we'll look at that in another video in the second year of A-levels.